Okay, today I am going to solve exercise 46.1 from the book Mathematical Physics written by H.K. Das. Okay, so this exercise is based on unit step function, second theorem, second shifting theorem, and about an integration theorem. Okay, so I think you all know about this. If you don't know about this, then first I think you should read this, and after that you come to this video. I mean, this is basically the problem solving video. I am not going to give any theoretical knowledge about this topic. I mean, this exercise also. So first of all, in HK Das, it is given the first problem. It is given f of t equal to t minus 1 for 1, t less than 2, and 0 for otherwise. So you can see that this is an unit step function. Okay, so I think you all know that how to solve this unit step function if you use in Laplace transform. So I am here writing a formula L of f of t minus a u of t minus a equal to e to the power minus s f of s. I am considering that you have all know about this formula. If you don't know about this, then please read this. Okay, so I will use this, but before that I need to rearrange this function. Okay, so I can write it equal to t minus 1, okay, and u of t minus 1 plus u of 2 minus t. Why I have here used 2 minus t? Because here 2 is greater than t and 1 is less than t. So t minus 1 and 2 is greater than, so 2 minus t, and after that I will change. That's doesn't matter. Okay, so t minus 1. Okay, now change t minus 1 u of t minus 2. Okay, I have already changed it. Okay, fine. So split it, t minus 1 into u of t minus 1 minus t minus 1 into u of t minus 2. Okay, that's no problem. Okay, but if you carefully see this, that here t minus a and here this is the algebraic term, and this is the unit step function. So this a, but here it is a equal to 1 and here a equal to 2, so this is not equal. So I need to make it equal. So I can replace it by I can replace this minus 1 by minus 2 plus 1. I can write it minus 1 equal to minus 2 plus 1. Okay, I can write it t minus 1 plus t. Okay, I can write it. So I will replace this. Okay, so now replace t minus 1 u of t minus 1 minus t minus 2 into u of t minus 2 minus u of t minus 2. I can write this. Okay, now it's okay. I think you can see this is 2 2 1 1. Okay, u of t minus 2. Okay, now take Laplace. Okay, so L of f of t equal to, individually I am taking Laplace. Fine. So here I will use the formula first two. For this first two I will use this, but this will not be solved by this formula. So that time I will write another formula. Fine. So here I can write it t minus 1 a equal to 1. So e to the power minus s. So I can write it e to the power minus s. And you have seen that f of s, it can be written as L of f of t, and here f of t equal to t. So I can write L of t. L of t equal to, you all know that it will be 1 by s square. Now minus L of t, here a equal to 2, so e to the power minus 2s by a square. Here same also L equal to L of t equal to 1 by a square. Fine. And here L of t u of t minus 2, but you can't use this formula. Here you have there in HK Das this is written that L of u of t minus a equal to e to the power minus s by s. Okay, I can prove it mathematically. Okay, you can also see this, the proof is also given in this book, but I don't need any proof. I just need to solve the problems. Okay, so I'm not here going to prove this. Okay, so L of u of t minus t, so you can see that a equal to 2, so minus of e to the power minus 2s by s. So this is the answer. Okay, now I am going to the second problem, and this is given that e to the power t u of t minus 1. So this is the second problem. Fine. So I need to here another formula will be used. Okay, so first of all I need to write this formula. I think you all know about this formula, and this is in HK Das you will see that there will be a heading theorem, and this theorem will be used here. So you L of f of t u of t minus a equal to e to the power minus s L of f of t plus. So this is very important formula for you. Okay, so this formula I think you need to in your mind, keep it in your mind. Okay, so here you can see that here e to the power s is equal to 1, so I can write e to the power minus s. Okay, now this L, okay, L, then bracket, okay, then f of t plus a, but we know f of t equal to, here f of t equal to e to the power t, so f of t equal to e to the power t, so f of t plus a equal to e to the power t plus a, clear? Okay, e to the t plus a, and also you can write e to the power t into e to the power a. Okay, now substitute this, okay, L of e to the power t into e to the power a, and this e to the power a is constant, so e to the power minus a into e to the power a, L of e to the power t, and you all know what is the value of L of e to the power t, so e to the power minus a into e to the power a into e to the power t equal to 1 by s plus a. This is the answer. Fine. Now I am going to solve the problem, third problem. Fine, but this is quite complicated. Okay, but focus on this. I think this will be more easier to you. Okay, so it is given 1 minus e to the power 2t by t plus t u to the power t plus cos hyperbolic t into cos t. Okay, so this is the problem. Fine. Okay, now 1 minute. Okay, I think I need to solve this by part wise. Okay, so first part I am taking as first part, and this is second part, and this is third part. Clear? So I am going for first part. So first of all, I need to solve 1 minus e to the power 2t by t, and I also break this L of 1 by t minus L of e to the power 2t by t. Here also you need a formula. Okay, okay. So the formulas you should keep it in your mind. Okay, otherwise you will stuck upon it. Okay, so I am not responsible for this. Fine. So here a formula will be used, and the formula is L of f of t by t equal to s to infinity f of s ds. Clear? So this formula you need to keep it in your mind so that you can solve this problem. Okay, so this is the formula. Okay, so I will use this. So here you can see that f of t equal to 1, and after that f of t equal to 2 to the power 2t. Fine. So you can write it by L of 1 by t. Okay, 1 minute. F of 1 by t. So okay, f of s. ठीक है, कोई बात. Okay, so L of 1 by t, f of 1 equal to f of t equal to 1, f of t equal to 1, and here the lower term is t. Fine. So I can write it s to the power infinity, because here s to the power infinity, and f of s ds, and f of s equal to, you can write L of f of t, and you know that f of t equal to 1. You can write f of s equal to L of f of t, and L of f of t, and you know f of t equal to 1. So here L of 1 into ds minus, okay, so here f of t equal to e to the power 2t. Okay, so this is quite interesting, s to the power infinity, okay, and L of e to the power 2t into ds. Clear? Okay, clear. Now you know L of 1 equal to 1 by s, so s to the power infinity 1 by s ds minus s to infinity e to the power 2t, so you can write 2 by s plus 2, okay, and ds. Okay, now what will you get? Log of s to the power infinity minus log of s plus 2 into s to infinity, and if you substitute this, then you will get the value log of s minus 2 by s. So this is the part 1 answer. Okay, now I am going for part 2. Fine. So part 2 you will need t of u of t. Okay, so here you can use this formula. Okay, because f of t equal to t, and here t minus a equal to 0. Fine. Okay, so you can write this formula e to the power minus t. So here you can write this by, okay, 1 minute. Okay, e to the power minus a equal to 0, so e to the power minus 0 into L of f of t plus a. Okay, so L of e to the power t plus a. I think I am doing something wrong. Okay, don't use this formula. Okay, because if you use that f of t equal to t, and if you use t minus 0, then I think this will be okay, easy. But you can write also the t minus 0. Okay, so t minus 0 u of t minus 0. If you can write this, if you see that t minus 0 u of t minus 0, then you can easily use this formula. Okay, I think this will be wrong. Okay, so e to the power minus s, e to the power minus a, e to the power minus a s f of s. Okay, I will use this. So e to the power minus 0 into f of s. S means f of s equal to L of f of t. So f of sorry, L of f of t equal to t. Okay, so L of t. Okay, and e to the power 0 equal to 1. So 1 by s square, because you all know that L of t equal to 1 by s square. I am not going to prove this. It is also a formula. Okay, you should know about this. Okay, then I am going for the third part, and here it is given L of cos hyperbolic t into cos t. Okay, so transfer this cos hyperbolic term into the exponential term. So L of e to the power t plus e to the power minus t by 2 into cos t. I can write this, and then I will break this. Okay, so L of e to the power t cos t by 2 plus L of e to the power minus t cos t by 2. And I think this is the quite interesting atmosphere to use fast shifting theorem. Okay, so fine. If you don't know about the fast shifting theorem, then I am requesting you that go read the book and know about the fast shifting theorem, and then come to this video. Okay, fine. So L e to the power t cos t, e to the power minus t cos t. So use fast shifting theorem, and you will get 1 by 2, because this is 1 by 2 constant. Common constant. Okay, so you can write s minus 1 by s minus 1 whole square plus 1. Why s minus 1? Because L of cos t equal to L of cos t equal to s by s square plus 1, and I have already said in my previous lecture that if I need to use the fast shifting theorem, and here this cos t multiplied by an exponential term, then this s will be replaced by s minus a if there is e to the power minus 2t. Okay, e to the power t. Okay, if e to the minus 2t, then s will be replaced by s plus 1. So here it will be s minus a whole square plus 1. So this is the fast shifting theorem actually. Okay, so s minus 1 by s minus 1 whole square plus 1 plus here I will get s plus 1 by s plus 1 whole square plus 1. Okay, and if you break this, then you will get 1 by 2 into s cube plus s square minus s minus 1 plus s cube minus s square plus minus s square minus s plus 1 plus s by what will be s to the power 4 minus 2a square plus 1 plus 2a square plus 3. Okay, dig this and you will get this term. Okay, and from here you will get 1 by 2, sorry, 1 by 2 will be removed. Okay, so you will get s cube by s to the power 4 plus 4. Okay, so 2 square. So this is the answer. Right. So I am going to the next problem, and next problem is about here I can write this. Okay. Okay. Next problem is okay. So next problem, it is given number 4, t square u of t minus 2. Okay. So I think if you want to transfer it, L of t square u of t minus 2, I think here it is easily use L of f of t u of t minus a equal to the power minus s into L of f of t plus a. You can use this formula. So fine. Okay. So fine. Here f of t equal to t square. That's okay. So here a equal to 2. So e to the power minus 2s. I can write it. Okay. Then L of. So here you can see that f of t equal to t square. So f of t plus a equal to t plus a whole square, and a equal to 2. Why I am use this t plus a? Because this formula minus s, so here minus 2s, and then L, and then f of t plus a equal to t plus a whole square. T plus a whole square. Now break this. E to the power minus 2s, L of t square plus 4t plus 4. Okay, then e to the power minus 2s, and then it is usually 2 factorial by s cube plus 4 into 1 by s square plus 4 by s. Okay. Then you can common it e to the power minus 2s by s cube into 2 plus 4s plus 4s square. Okay, so this is the answer. Very simple. Right, now I am going to the number 5. Here it is given that sin t u of t minus 4. Same problem, like this. Okay, so let's solve this. So L of sin t u of t minus 4, but here they have changed one thing, that here a equal to 4. Okay, but here a equal to 2, so here a equal to 4, but I have no problem. So e to the power minus 4s, and then L of here f of t equal to sin t, so I can write it by L of sin t plus 4, because t plus a equal to 4. So t plus 4. Okay, now bring this for this, and you know L of sin t plus 4, sin t cos 4 plus cos t sin 4. Okay, I can write this. Now e to the power minus 4s, and this is very easy. Cos 4, this is constant term, and sin t, L of sin t equal to a square plus 1, plus here sin 4 is the sin term, and cos t is equal to a square plus 1. Okay, but here and small s here will be. Okay, so this is the answer. Now I am going for number 6. Okay, so number 6, it is given that f of t equal to k of t minus 2 into u of t minus 2 minus u of t minus 3. Okay, so I need to solve this. Okay, so first of all I need to take Laplace. F of t equal to take this Laplace, k of t minus 2 into u of t minus 2 minus u of t minus 3. Okay, fine. Now you can see that okay, what you need to do. ठीक है, कोई बात नहीं. Okay, L of k of t minus 2 u of t minus 2. Okay, it's okay, minus k of t minus 2 into u of t minus 3. But and a problem arises that here a equal to 3, but here a equal to 2. So I need to make this equal. So I can write this minus 2 by minus 4 plus 1. Sorry, admit. Minus 3 plus 1. I can write this minus 2 equal to minus 3 plus 1. I can write this. Yeah? Okay, so this will be my next strategy. 1 minute. Okay, so this will be my next strategy. Okay, so I am doing it. Here I can use this formula. Okay, first of all I need to write t minus 2 into u of t minus 2 minus k of t minus 3 u of t minus 3 minus k of 4 into t minus 3 plus 1. Okay, so minus 3 plus 1. Okay, so this is 4. Okay. Now you can easily use, because individually, so it will be minus 2s by L of t equal to s square minus k, here 1k will arrive, and here e to the power minus 3s by t, so a square and also k. Okay, and after that minus k into e to the power minus 3s, okay, by s. Why this is s? Because this is not the unit step, this is the single unit step function, and you know that k of I mean sorry L of u of t minus a equal to e to the power minus s by s. This you need to know about this, so I have used this formula here. So e to the power minus 3s and k is constant. This is the answer. Okay. So enough for today, and I have already solved 6 problem, and there is also 4th problem remaining, and I will solve it in this next video. Okay, subscribe my channel. Okay, if you think that you are being helped by me, okay, then subscribe. Thank you.